Okay, so the first step in solving this problem is to solve the homogeneous equation, which is to solve our y double prime minus 3y prime plus 2y is equal to 0. It has auxiliary equation r squared minus 3r plus 2 equals 0, which factors into r minus 2 and r minus 1 equals 0. So the r1 value is 1, and the r2 value we'll say is 2. So our two solutions are y1 of t is equal to e to the t, and y2 of t is e to the 2t. We now want to look at our particular solution. So we look at our forcing term first, our 5 times t, and we'll notice that there's no way to take a linear combination of exponential functions and form a linear function from that. So we have linear independence, and we can just build our particular solution as a generic linear function. So our yp of t is going to be some unknown coefficient a times variable t plus another coefficient b. And this is just a linear function. Think of it as mx plus b. We now need to take the first and second derivatives. And by the way, this is step 2 of the process. So we take the first and second derivatives. So yp prime of t is just a constant a. And the second derivative, of course, is 0, because the derivative of a constant is 0. We now substitute into the original differential equation, which is up here. So in place of the y double prime, we're going to have 0. Then we're going to have minus 3 times the y prime that we found, which was the constant a. And then it's plus 2 times the original yp that we have, which is the at plus b. And now this must match the forcing term 5t. We can now multiply this out, and that's going to give us a negative 3a plus 2at plus 2b is equal to 5t. And then from here, we can now match coefficients and solve for a and b. So if we first look at constants, we've got negative 3a plus b equaling 0. So negative 3a plus 2b is equal to 0. And then for the linear, we've got a 2at that must match up with the 5. So that means that 2 times a must equal 5. So that immediately forces a to be equal to 5 halves. And then we can solve for b, since 2b above, so we can write that in red. So 2b is equal to 3a. So 2b is equal to 3 times the 5 halves, which is 15 halves. And then dividing both sides by 2, b is equal to 15 fourths. So our particular solution is yp of t is equal to a times t, so that's 5 halves times t plus b. So again, when they ask in a problem for a particular solution, that is what we actually want for the solution. But that by itself isn't the full solution of the problem. Instead, we want the general solution, and that's going to include our two arbitrary constants. So we're going to have our y of t being a c1 e to the t plus c2 e to the 2t, and then plus the particular solution of 5 halves t plus 15 fourths. And this is the full general solution of the inhomogeneous differential equation.